Ayan, meron na guys. Okay, so pasensya na nagkaroon ng technical problem dito sa laptop ko. Nag-switch muna ako ng device. So we will continue what we were discussing last time. So, ito tayo, solve natin na itong part na to. Wait, tama ba na-solve na ba natin to? Or, anyway, so, ito, example dito, a dihedral angle is 120 degrees. The distance of a point inside the angle from each of its faces is 8 centimeters. Find the distance between the feet of the two perpendiculars dropped from the given point onto the faces. So, magdodraw tayo ng figure dito. Ayan, so, ganito. And then dihedral angle na given. So, we are going to draw a 3D figure like this. Since dihedral angle siya, mag-draw tayo ng dalawang figure. Ayan. Anyway, kita nyo ba? Okay, short recall muna. Sige, sige. Hindi ko kasi nababasa yung mga chat nila rin sa mga. Anyway, where are we now? Make sure that recall muna tayo. So, the last time we started with the lines and planes and space. So, ang ayan, dito tayo. I-recall muna natin tong lines, planes, and angles in space. So, ayan, solid geometry is yung geometry in space, yung hindi siya nasa same plane. In short, meron siyang iba-ibang parts. It's not on the same plane. It can be in other parts like this one. It means it's a 3D figure if it's solid geometry. Kasi kung in the same plane, hindi plane geometry yun. Anyway. So, ayan. So, alam niyo na siguro yung why study solid geometry. Yung um, or discovered, organized, valuable information about the 3D space. And then, analytical thinking and logical thinking. Mapapractice, then arithmetic and algebra computation, you know. Ayan, alam niyo na siguro yung plane na it's a surface such that a straight line joining any two points in it lies wholly on the surface. Yun ang plane. Buong plane, it lies wholly on the surface. So, curved surface in the plane figure, no portion no portion of which is a plane that's curved, and the whole points lie in one plane. That's a plane figure. And then postulates. A plane is determined by a straight line and a point not on the line. So just like the example na merong plane, meron isang plane and the line not on the plane. There's a plane and there's a line and a point that it's not on the line. Oh, Joe, wait.
Ayan guys, can you hear me na?
Okay na, thank you. Rinig na. Maayos.
Ano yan?
Okay na, rinig ng maayos.
Okay, so
Continue natin tong postulates. We have postulates given here na ang plane is determined by a straight line and a point not in the line. Merong line tapos isang point, then mas sakop nung anyway, draw ko siya sa gilid Ayan. Ayan isang line and isang point not on the line yan. Ayan, parang ganyan. Let this be A, this is B. No, that should be B, not D. B dapat yun. Ayan, let this point C, and this is plane M, ayan, ganyan, parang ganyan siya. Anyway, let's continue. Let's continue. So this is another one, postulate to that an infinite number of planes can be passed through a point in space. So yung infinite number of planes, magpa-pass through siya sa isang point. If you can see what's on the figure here.
Marami siyang plane, right? So, ayan o, eto siya o. Ayan, yan yung maraming plane. Ito, ayan, ayan. Ito. And ito yung nag-iisang point na yan. It passes through 1 point in a plane. And then postulate number 3, a plane may revolve about a line in it as an axis. And as it does to revolve, it can contain any particular point in space in one and only one position. Hindi siya nagbabago. Hindi nagbabago ang position. It can contain a particular point in space. Yun, hindi nagbabago position. Pero yung plane, nagre-revolve siya about a line in it as an axis. If you can see here, that this is the line you see right there. Yan. Ito yung line din. Nagre-revolve siya. Ayan, no? Ganyan. Ganyan. Ayan. Tapos, ayan, ganyan. Ayan, parang ganyan. Ganyan ang, nagre-revolve yung plane in a line. On a line, I mean. As an axis. Then, continue. Okay. So, we have another definition here. Lines and planes in space. Definition number 2, that the intersection of two or more geometric figures consists of the set of all points common to the geometric figures. And corollary 4, if two planes intersect, their intersection is a straight line. Ayan. Based dito sa corollary 4, na if two planes intersect, ayan no, eto, tapos, ayan, yan dalawang plane na yan, it intersect. And this is their intersection, which is a straight line. Ayan no. If you can see plane, I mean line RS, that's the intersection of planes MN and PQ. You know, intersection of two or more. And meron siyang dalawang geometric figures. Ayan, the intersection of two or more geometric figures consists of all the set of all points common to the geometric figures. Yung RS, yan. Yan ang common. Okay. And then, next, we have here lines. We still have this that remarks that if two points of a straight line lie in a plane, the whole line lies in that plane. The whole line lies in that plane. Okay. So to mention the long points, you can see point AB right there. Ano, eto. Tapos, eto. Ayan. Ayan. Okay, okay. Naririnig na ba? Naririnig malakas na ba or not that much?
Hello, hello. Ayan, naririnig na ba? Malakas na ba? Or hello, hello, hello. Ayan, naka-Bluetooth pala siya. Kaya ayan. Now, I'm sure I can be heard loud and clear. So, continue tayo dito. So, ayan. Ayan. So, continue tayo. Meron dalawang points of a straight line. Ayan. Then the whole, you can see point A, B is on the plane. Points of a straight line yung A and B, and it lies on the plane. Yan, yung buong line AB lies on the plane. And letter B, a straight line can intersect plane in not more than 1 point. If you can see that there's a straight line here on the figure, ayan o, yung linya na yan, ayan, it lies on the plane. No, I mean, no. It is a straight line. It intersects a plane in not more than 1 point. So it means that the point can only be one. It cannot be greater than one. It cannot be less than one. So this is a point where the line is intersecting the plane. That's the point. Anyway, next, let's continue. Ayan, ito pa rin, lines and planes in space. We're still on the lines and planes in space at a straight line, not in a given plane, and not parallel to the intersect plane. Only one thought. Diba? Not parallel, not in a given plane. Ayan, kagaya nung sa figure na to. It's not in a plane and it's not parallel. Ayan siya, oh. It's not in a plane and it's not parallel. Ayan, oh. 'Di ba hindi siya parallel, oh. At wala rin siya sa plane. Kaya 1 point lang, oh. Okay, so definition number 3. The foot of the line is the point of intersection of the line and the plane, or of the line and the second line. Ayan, no? You can see on plane MN, point B is the foot of the line, or the foot of the plane. Wait, no, the foot of the line, I mean, is the point of intersection of the line and ayan, no, yung foot of the line is point B. And it's on the plane. Yan yung foot. Yung paa ng linya. Foot of the line, let's say. The point of intersection. Ayan, point of intersection is yung B kasi yung plane MN, line AB, nag-intersect. Yung point of intersection. Okay, point of intersection, yung B. So the point of intersection can be called the foot of the line, then point B is the foot of the line. Next. Eto, a line is perpendicular to a plane if it is perpendicular every line that is passing to its foot. If you can see that there's a figure here, plane MN, then there are a lot of lines. Okay, let me read first definition 5 that a normal to a plane is a line perpendicular to the plane. So if you can see, line AB is ito siya, perpendicular, ang line na ito, yan. Line AB is the normal to a plane. Kasi nga it is perpendicular to a plane. And then, the definition 4, we have a lot of lines here. Definition 4, we have line CB, line DB, EB, FB, and GB. That is all on the same plane, which is plane MN. So, that is a perpendicular to a plane. Kasi it is perpendicular to every line in the plane passing through its foot. And yung foot of the plane is yung point B, let's say. From definition 3, that is yung point B. Anyway, let me just... Ito, yung foot of the plane, yung point B, yan. And then, yung mga line CB, line DB, yan ang mga perpendicular to a plane. Yung lines na yun kasi it passes through its foot, the foot of the plane, point B. And line AB is the normal to a plane kasi perpendicular siya to plane MN. Next. Ito na dito tayo sa theorems. Ito ang kailangan ng proving. Given that, okay, let's read first theorem 1. If a line is perpendicular to each of two intersecting straight lines at their point of intersection, it is perpendicular to the plane of those lines. Ayan, meron tayong proving dito. Given that line AB is perpendicular to each of the intersecting lines BC and BD at B, point B, let's say. Plane M contains line BC and line BD. So, ang ipoprove natin dito is yung line AB perpendicular to plane M. So, may proving to. Gagawa tayo ng two-column proof dito. Okay. So, meron pa tayong mga ibang theorems dito that line segment theorem. May line segments are equal if they join any point in the perpendicular bisector of the line segment to the endpoints of the segment. And theorem B, in a plane, a line passing through 2 points, each equidistant from the endpoints of the line segment, is a perpendicular bisector the segment. So let me show you the figure for this one. Okay, where is it? Ito siya, oh. Let's start first with theorem A. I'll draw it on the left side. So we will have it here that line segments are equal. They join any point in the perpendicular bisector. Ayan, let's start here. Ayan, ganyan siya. Di na naman. B dapat. Mali. Nawala siya. Wait. Okay, so let's go back here. The line segments are equal if they join any point in the perpendicular bisector of a line segment to the endpoints of the segment. And then, so we have here the perpendicular bisector here. Yan, ayan siya. Ayan. So you can see here on the figure that line segments are equal if they join any point in the perpendicular bisector. Ayan, so ang line segment, yung meron tayong line segment AB and the perpendicular bisector of a line segment which is line CM. Ayan, then meron tayong line segments. Ayan, equal siya. They are parallel or I don't know if parallel or congruent, pero equal siya. Equal yung line segment AC and line segment BC. Kasi, ano, kasi they join any point in the perpendicular bisector of a line segment to the endpoints of the segment. We have endpoints A, B. So, this is theorem A na equal ang line segments A, C, and BC. Kasi nga they joined any point in the perpendicular bisector. Any point kahit saan. Pwede rin siya dito sa baba. Pwede rin siya sa gitna. Pwede rin siya sa gitna eh. Ayan no. And we can label that point as point E. Ayan, equal din yan. Ayan, yan, pwede rin siya. Any point kasi in the perpendicular bisector. Pwede yan. They are equal then to the end. Ayan no, magkadugtong line segment AE and line segment BE. They are equal as well. Next is theorem B. In a plane, a line passing through 2 points, each equidistant from the endpoints of a line segment is perpendicular. Is the perpendicular bisector of the segment, rather. So we are going to draw another figure for this one. Ayan, ito yung figure na. Ganyan din siya. Kasi in a plane, a line passing through 2 points. Ganyan. A line segment passing through 2 points, each equidistant from the end points. Ayan, no? Ayan. Ganyan din siya. Label as A and this is B. Ayan. The end points of a line segment. Ayan, no? A line passing through 2 points. Ganyan. 2 points. Passing through 2 points, each equidistant from the endpoints of a line segment. Ito yung line segment AB. Line segment AB siya, yung line segment. And we have the line segment here. Let's label this one as C. Point C. We have the line segments AC and BC again. And then it's the perpendicular bisector of the segment. Ito siya. We will label this one as point D. Ayan, no? So we can say that CD is a bisector of AB, line segment AB. Kasi in a plane, a line passing through 2 points, each equidistant from the endpoints of the line segment. Ayan, no? Yung line passing through 2 points. Ito yung line CD. Yan yung line passing through 2 points. We have point D and point C. And each equidistant from the endpoints of a line segment, which is line segment AB, point A and point B. And we have two line segments, point AC and point BC. They're equal. A line passing through 2 points, each equidistant from the endpoints of a line segment, is a perpendicular bisector of the segment. Ayan, no, yung CD, perpendicular bisector siya ng segment AB. Kasi a line passing through 2 points is a perpendicular bisector of the segment. Ayan, no, meron yung line. So we will introduce this. So we will now continue since we all know the theorems here. So let's continue. So this is the two-column proof. We have ayan. So ayan. So this is another problem. We have here a problem that ABCD is a rectangle with line AB is 6 inches and BC is 4 inches. CP is drawn perpendicular to CD and BC at C. If PC is 3 inches, find the length of AB. So we will first find muna the length of AC in inches kasi nga para mahanap natin yung line AB. The line AP is there. The length, because the line's already there. So we should not say we find line AB because it's already there. So we should properly say it, the length of line AB. So I'm sure we all know this one, that 4 inches, 6 inches. We can do Pythagorean theorem here since we are looking for the hypotenuse. So as you can see that the Pythagorean theorem is the square of the length of the hypotenuse is equal to the sum of the squares of the length of the two other legs. So we'll just label it like this. We'll have it like this, where C is actually AC, and then A is okay. That's A, not it looks like a 9, but that's A. That's A is CB, and then B is AB. So we will have it like this. C squared. Okay, I'll just do the short method na lang. Para mabilis tayo. Is equal to the square root of. Now let's write the squared form. So that's 16 plus 36. Ang gulo ng sulat ko. Mukha siyang multiplication. Pero addition po talaga yan. Plus 36. So, the answer here, that is 2 square root of 13 inches. Nye, gulo. Gulo ng sulat ko. Man, I cannot write 13 properly. Ayan. 2 square root of 13 inches is the value of C, or the value of AC, rather. Square root of 13 inches. Now we have already the value of AC. Now we can now find the value of AP since we already have the given. So let's do again the shortcut method. The short method na lang para mabilis. Then square na agad natin. Let's write down 9 plus 52 AB is equal to the square root of 61 inches. Ayan. Ayan siya. And we also have another example here. Let's proceed. Another one. It goes the same. And we'll actually do the same for the problem here. We'll do the same. And since we have here the ABCD is a square, each side of which is 6 inches. CP is drawn perpendicular to both BC and CD. And we are looking for the length of line AP. If PC is 8, then find the length of AB. So we are gonna find first the length of AC. And since if you can see that AB and BC are both 6 inches, we can use here the isosceles triangle theorem. So if you can see that. So the isosceles triangle theorem is C is equal to A square root of 2. So therefore, AC is equal to AB or BC square root of 2. So since we have, so we will write down C is equal to AC. And if you can see that this is an isosceles triangle, so we will have C is equal to 6 square root of 2 inches. Ayan. And now to find the line. Now to find the line AP. I mean the length of line AP. Not find the line AP. Again, another error committed. Anyway, let's continue. So we'll be looking for the length of line AP. It's just the same, just like our first example, but this time this is an isosceles triangle given. So we will now square this one. So we will have 72 plus 64. So line AP is equal to the square root of 136. And then we can still simplify this one. So the factors of AP, or the square root of 136, we can write it as the square root of 4 and the square root of 34. Okay, then. So Let's write down it. So we can simplify the square root of 4. So it's 2 square root of 34 inches. Ayan. So let's continue. Let's continue. And we have here another example. We have here another example. So example 3, that a rhombus ABCD is a rhombus whose diagonals intersect at O. AB is equal to 8 inches and angle BAD is equal to 60 degrees. DP is drawn perpendicular to DC at D. Point D. If PD is 3 inches, then we are going to find the length of AQ. So we are going to solve it like this. So since we have the given angle of 60 degrees, so angle BAD is 60 degrees. So this is the one that's 60 degrees. And we can divide, if we are going to divide it, since we have line AC that cuts through the angle, we can have 30 and 30. This is, oh no, that's a 10. That's not a 30. 30. Anyway, I'm not gonna write it anymore. Just think of it as 30 degrees. Just assume that that's 30 degrees. So we have here the given. We will look first for, since this is 8, and this is also 8, and this is also 8. So we will have it like this. And since we have here the value of C is 8, since we are looking for the value AD, let's equate AD to C. And then let's label. Yeah, we'll first look for this figure here. And we already have 8 as our hypotenuse here. So this is 30 degrees. This is 30 degrees. Mali na lang. Hindi na siya maayos. That's 30 degrees. And then if you will remember the 30-60-90 theorem, that the value of B is equal to C square root of 3 over 2. We'll have it like this. C square root of 3. C is square root of 3 over 2. Like that. And we will look for line AO, the length of line AO. So we will have it AB square root of 3 over 2. And then we have the value of AB, which is also 8 degrees. Since this one is 30 degrees. So the line AO is equal to AO is equal to, since the value of AB is 8 square root of 3 over 2. So the value of line AO is equal to 4 square root of 3 inches. Yan. And since this is a 30-60-90, line OB and line DO is 4. If you remember 1, 2 square root of 3, that the opposite of 30 degrees, that's equal to 1. And the hypotenuse is 2 and the adjacent is square root of 3. That goes the same here. That Anyway, let's look for line OB. We'll find line OB, the length of line OB in terms of line AO. So we can do OB is equal to AO square root of 3. Can't write square root of 3 properly. Square root of square root of 3 over 3. So we already have, let's just write that here. OB is equal to 4 square root of 3 square root of 3 over 3. Now, if you can see that we have doubled, we have the square of the square root of 3, so that's 3. So we can now cancel this out. We can cancel out 3. So the value of OB is equal to 4 inches because this is a 30, 60, 90 triangle. Anyway, now let's look for the other values. We already have the value of AO and the value of OB. The value of OB. So we can now look for the other values. And the value of AD is 8 and AO is 4 square root of 3 inches. So we can now look for the value of DO. Now to find the let's find the value of DO in terms of AD. DO in terms of AD. So our formula for this is the value of DO in terms of AD is AD over 2. AD over 2. So we can have DO is equal to 8 over 2 and DO is equal to 4 inches. Okay. And now since we already have the value of DO, we can now find the value of P PO. And since, oh, never mind that. Don't mind that, chat head. And then we have here the value. We are now going to look for the value of DPO. So let's draw a right triangle here. We have P, we have D, and we have O. So PD is 3 and DO is 4. So if you can see Pythagorean triples, so this is 5. And that is the value of PO. There's another, and to find, there are more ways to find this one. I'm telling you, we should not just stick to this solution. There are more approaches to this one. Since this is mathematics, mathematics have different approaches, and you forgot that there's no Supreme Court in mathematics to settle issues, disputes rather. So you can do anything you want. If you want to do the long method, no problem. If you want to do the short method, no problem as well. We can use also some trigonometric functions to find these values. Anyway, let's proceed. So we have here that the distance from a point to a plane is the length of the perpendicular from the point to the plane. So the point, the, the distance from a point to a plane. Again, what is the point to a plane again? Point to a plane is the length of the perpendicular from the point to a plane. So the distance from a point to the plane, so line AB is the point to the plane. And the perpendicular from the point to plane is line BC. If I'm not mistaken. So we have here the example that line AB is perpendicular to plane M at B. If a line is a line BC is a line segment in M 5 inches long and AC is 13 inches long. So how far is A from plane M? So let me draw an example here again. Let me do the illustrations here again. So BC is 5 and AC is 13. So again, this is Pythagorean triples. The answer is 12. If you can see that 13 squared is 169. So we made use of Pythagorean theorem again, where the square of 12, the sum of the square of 12 and the square of 5. So that is 144 and 25. So the answer is 169. So we are actually looking for the value of AB. So we are going to subtract 169 to 25. So we will get 144. And we find the square root of 144, it's 12. So that's why the answer is 12. So yeah, that is the point to a plane. So the distance from a point to a plane is the length of the perpendicular from the point to a, yeah, the point to a plane is line AB. You can see that point to a plane, that the distance from point A, point B, if you can see that point B is the foot of the plane, and CB is the normal to a plane. The normal to a plane, and the line AB is actually the point to a plane, the distance from a point to a plane, and that is the perpendicular line from the point to the plane. So let's continue. And we also have another proving here. That we also have another theorem here that if two line segments are drawn from a point in perpendicular to a plane and meet a plane at equal distance from the foot of the perpendicular, they are equal. You can see that there are two line segments are drawn from a point in a perpendicular to a plane and meet the plane at equal distances. Yeah, line AB it is the point to a plane, the perpendicular to plane, and meet the plane at equal distances. Yeah, there are two line segments from the foot of the perpendicular. You can see that perpendiculars D and C. The perpendicular, the normal to a plane, DB and CB, and the foot of the plane is B. And there are line segments drawn from the point in a perpendicular to a plane, which is line AB, and point A. There are two line segments drawn from point A, and it is line AD and line AC. So that is the line segments. Those are the line segments based on the figure. The line segments on the figure. Next. If two line segments are drawn from a point in a perpendicular to a plane at unequal distances from the foot of the perpendicular, the more remote is greater. So two line segments are drawn. Again, line AD, line AE, and line AC, drawn from a point perpendicular to a plane. Meet the plane at unequal distances from the foot of the perpendicular. You can see that the foot of the perpendicular, the normal to a plane, DB and CEB. If you can see that the more remote is greater, that line BEC, that line AC is greater because it is unequal, and you can see that line BC is longer than line BD. So we can say that it is the more remote is greater. You can see line AC is longer than line segment AE because it is unequal. The line segment is drawn from point A to the plane, and if you can see that the more remote is AC, and that is greater because the perpendicular line BC, the normal to a plane that is longer than BD. Next, definition 7. A line is parallel to a plane if the line and the plane cannot meet. Yeah, I mean it's parallel, so it means that they cannot meet. As you can see that line DP and line AB are not parallel. If you can see the figure, that a line and the plane is parallel if they cannot meet. Parallel to a plane. You can see line DP right there. They can't even meet with plane M. A line is oblique to a plane. If it is neither perpendicular nor parallel to the plane. If you can see that line DP is not perpendicular to line M. So definition 9, two planes are parallel if they cannot meet. You can see na pantay siya. Ibig sabihin nun, parallel. Ganon din kung sa lines may parallel. Ganon din sa planes. So definition 7, a line is parallel to a plane. Ibig sabihin, hindi sila tatagpo. Kasi nga, pinagtagpo sila pero di tinadhana. Hindi, joke lang guys. Joke lang yun guys. We're not talking about love here. We're talking about solids here. That if it's parallel, then di sila pinagtatagpo talaga eh. Di talaga sila meant to be. Kapag parallel, ibig sabihin nun hindi talaga meant to be. Hindi sila pinagtatagpo. Parallel lang sila. A line is parallel. Hindi sila nag-meet. Pag hindi siya perpendicular or parallel, ibig sabihin oblique. Ayan o, oblique yung DP, pati yung plane M. Then, two planes are parallel if they cannot meet. No? Yung dalawang planes na pinagtagpo, pero di tinadhana. Kasi nga parallel eh. Hindi sila pinag-meet. Parallel sila. Nagtagpo lang, pero hindi tinadhana yung dalawang plane. Anyway. Ito, we have here theorem 6 again, that if a line is parallel to a plane, the intersection of the plane with any plane passing through the given line is parallel to the given line. Okay, if you can see here that if a line is parallel to a plane, the intersection of the plane with any plane passing through the given line is parallel to the given line. Okay, so let me just line CD is siya, intersection. Intersection of the plane with any plane passing to the given line is parallel to the given line. If you can see that plane, there's plane M in here. And we have line CD on the plane. You can see that line AB is parallel to plane MN. Ayun, no, parallel yung line AB sa plane MN at plane AD through AB. Intersecting plane MN at line CD. And yung line of intersection, yung CD, and then yung line AB is parallel to plane MN. Let's imagine na merong line, yung line din ng MN kung sa plane geometry yan. Line MN is parallel to line AB. And yung plane AD, ayan yung buong plane na to. Ayan. Yan yung plane na yan. Intersecting plane MN in line CD. Ano yung true AB? Plane AD, true AB. Ito yung line A. Ayan yung line AD intersecting plane MN in line CD. And ito yung line of intersection natin sa plane. It is a straight line. Line CD. Yun yung line of intersection natin. Ayan. So, let's continue na. Ito, line CD. So, to theorem 7 to. It's not theorem 9. I just what I've said. If one of two parallel lines is perpendicular to a plane, then the all others also perpendicular to the plane. If you can see that one of two parallel lines is perpendicular to a plane, as you can see that AB and CD are parallel, and AB is the perpendicular to plane MN. So if you can see that the other is also perpendicular to plane, so line CD is perpendicular to plane MN as well. If you can see that one, which is AB, one of two parallel lines, which is AB, is perpendicular to plane, which is plane MN, then it's also perpendicular. Line CD is perpendicular to plane MN as well. And you can see na one of two parallel lines. Parallel lines of AB and CD. Then perpendicular yung AB. So perpendicular din CD, and we have proving for that as well. And then, anyway, water break muna. Inom muna ako tubig. Okay, so let's continue. Theorem 8, if a line is perpendicular to one of two parallel planes, it is perpendicular to the other. And theorem 9, two planes perpendicular to the same line are parallel. Ayan, no, if a line is perpendicular to one of two parallel planes, then it is perpendicular to the other. Ayan, no, itong line na to, it's perpendicular. I mean, yeah, line AB is perpendicular to plane M. And if, like, let's say if line AB is perpendicular to to plane MN rather, because we have two parallel planes, which is plane MN and plane RS, and it is perpendicular to the other. And if you can see that line AB is perpendicular to plane MN, because it's perpendicular to one of the two parallel planes, let's say MN, plane MN, then it is perpendicular to the other as well. So if line AB is perpendicular to one of two parallel planes, let's say plane MN, then it is also perpendicular to plane RS. And then two planes perpendicular to the same line are parallel. So we have here the common planes MN and planes RS, and planes MN and RS. They share the common line, which is line AB. So, and it is line AB is perpendicular to both planes. So we can say that plane MN and plane RS ay pinagtagpo pero di tinadhana. In short, parallel. Parallel sila. Di talaga sila di talaga si plane MN ay hindi talaga para kay plane RS kasi parallel sila. And then theorem 10, if a plane intersects two parallel lines, the lines of intersection are parallel. So, parang ganito yan. Let me draw a figure again. Ayan, no? Parang itong parallel lines, parang ganito rin ang dating niya. Sa 2D figure, pag plane geometry siya, ganyan. Na if a plane intersects two parallel lines, then the lines of intersections are also parallel. Then, parang sa plane geometry, if two lines are cut by a transversal, they are parallel. I don't remember what postulate or theorem is that. Pero parang ganun ang dating niya. Na may intersection niya, they are parallel. The lines of intersection are parallel. So, parang ganyan din sa 3D. So, we have here the figure here. Ayan. So, parallel yung dalawang planes and merong one plane that intersects these two parallel planes. Then the lines of intersection are also parallel. If you can see here, if we look into this figure that planes MN and RS are being intersected by plane PQ. So we have the lines of intersection, which is A, B, and CD. So we can say that lines A, B, and CD are parallel because they are lines of intersections, and the lines of intersections are parallel. Okay, let's continue. Theorem 11, if two intersecting lines are each parallel to plane, the plane of those lines is parallel to that plane. You can see two intersecting lines are each parallel to a plane. Then those lines are parallel to that plane. So we can see that there's line AB and CD intersect at E. Yeah, that's a point of intersection, which is E, and A, B, and C, they're parallel to plane M. Plane N, rather. If you look into the figure, A, B, and C, they're parallel to plane N. Plane M is the plane of A, B, and C, D. Well, that goes the same for plane N, that G, H, and I, J are in, are parallel to plane M, and they intersect at GH, and IJ are intersecting at point F. So they are parallel. So points E and F are parallel. And then the two intersecting lines, CAB and CD, are parallel to GH and IJ. So it means that the plane of those lines, the plane of those lines is parallel to that plane. So we can say that plane, and since that's A, B, and C, they are at point M, and so they are parallel to the other plane, which is G and H, I and J are parallel, are on plane, and so the planes are parallel. Planes M and N are parallel. Next is theorem 12, that two angles in the same plane have their sides parallel and extending in the same direction. They're equal and their planes are parallel. Two angles in the same plane have their sides parallel. Extending in the same direction, they're equal. The planes are parallel. So yung angle ABC sa plane MN, then BA and BC. Ayan, extending, they're equal, planes are parallel. So may two angles tayo, ABC and DEF. Yung ABC ay nasa plane MN, and RS yung DEF. And BA and BC parallel to ED and DEF. Ayan, parallel siya kasi nga two angles in the same plane. Other sides parallel. Extending in the same direction, yeah, they're equal. And yung planes ay parallel. Parallel yung MN, pati RS rather. And lying on the same side of line BE. Next. Theorem 13. Yeah, Theorem 13 na nga. Na if two lines are cut by three parallel planes, their corresponding segments are proportional. Ayan, no, meron tayong plane MN, PQ, tapos RS. So, meron tayong three parallel lines, AC, EH, and BD. Ayan, then there are two lines are cut by three parallel planes. Ayun, no, two lines na AE and B, lines A, B, and lines C, D. And meron tayong three parallel planes na MN, PQ, and RS. Then their corresponding segments are proportional. So we can see that line segments AC, EH, and BD, they are proportional because they are cut by three parallel planes. As you can see that the parallel planes MN, PQ, and RS intersecting line, they intersect line AB and AEB and CD in CDHD respectively. So they are proportional. AE proportional to EB and CH is proportional to HD. You can see that these proportions are equal. You can see we have AE and EB, CH and HD. Yeah, they are proportional. They are equal as well. Ito naman sa dihedral angle naman tayo. You know this already, I'm sure, that the dihedral angle is the figure formed by two planes meeting in a line. Yung edge ng dihedral angle, yung line of intersection of the planes. Yung faces, yung planes. And then yung intersecting planes, A, B, and C, D, form the dihedral angle, whose edge is BC. And A, B, C, D. Yun ang angle. Yun ang dihedral angle. A, B, C, then D. Because we have plane A, B, and plane C, D. And yung edge is BC. Ayan. Yan ang dihedral angle. A, B, C, D. So we have plane A, B, and plane C, D. And BC is their edge. Next. Ito plane angle, ang dihedral angle is the angle formed by two straight lines. So kung may dihedral angle, may plane angle din tayo. Pang yan yung angles, if you know. One in each face. You can see that line PM, line PN, yan ang straight lines. Yan ang plane angle. Perpendicular to the edge at the same point. Edge is EG. And then we have plane beta and plane alpha. Then it's read as the plane dihedral angle is the plane angle of the dihedral angle is MPN. Then the dihedral angle is beta, EG, alpha. And we have the plane angle of a dihedral angle. It's the measure. Yung measure ng plane angle is yun din yung measure ng dihedral angle. And the definition A, we have adjacent dihedral angles or dihedral angles which have the same edge and the common face between them. So meron tayong adjacent dihedral angles which have the same edge and the common face. So ang edge is AB. So we have a common face between them. We have plane M and plane P. Ayan, yan. Ang common face natin is kasi adjacent dihedral angles are dihedral angles with at yung edge natin. And then yung common face, ito, yung common face ito, yan ang adjacent dihedral angle. Kasi, ito, pati ito, yan, dihedral angle. Ito ang adjacent dihedral angle, yung nasa gitna. I mean, yan yung common face. Then vertical dihedral angles are dihedral angles that have the same edge and have the same edge, yeah. And the faces of one are the prolongation of the faces of the other. Parang yan yung vertical angles, di ba? Ganito. Eto, tapos, ayan. Yan, ganyan din sa dihedral angles. Meron din tayo. Yan. Di lang yan sa plane. Sa solids din, meron din tayong vertical angles. Vertical dihedral angles. Ayan, no, ito ba? Meron din tayong vertical dihedral angles. So, that is, yan, if I'm not mistaken, parang ganyan siya eh. Ayan, no, yung, if you can see the shaded area and the not shaded area there. Yan, ang vertical dihedral angles. Ayan, no, ito, tapos yung nasa loob yan, broken lines na. Ayan, parang ganyan. Ay, mali. Continue. Ito, equal dihedral angles are the dihedral angles which can be made to coincide when one plane meets another to form equal adjacent dihedral angles. The dihedral angles are right dihedral angles. When one plane forms a right dihedral angle with another plane, the planes are perpendicular to each other. Parang lang yan yung linear, pero equal dihedral angles are the dihedral angles that need to be coincide. If you can look into the figures, let's make it break down at the definition number 10. We have definition 10 that equal dihedral angles are the dihedral angles made to be coincide. They are made to coincide. Ayan, eto siya, dihedral angle. Ayan, tapos eto. Ayan, yung sa taas at sa baba. Ayan, equal yan. Ganun din dito. Ayan. Yan ang nagko-coincide yung mga dihedral angles. And then, next is definition 11. When one plane meets another to form equal adjacent dihedral angles, the dihedral angles are right dihedral angles. So, parang linear pair, ganito. Ganyan. Ganyan din sa solids. Ganyan din. Ganyan siya. Equal yan. You can see that they are forming a right angle. Ayan, o ganito. Ayan. Ayan. Ganyan. They form a right angle. Kasi one plane meets another. Ayan. Buti pa ang dalawang planes, di ba? Yung adjacent, di ba? They're meant to be adjacent. Tinadhana na rin sila finally, di ba? When one, yeah. Let's not do that right now. Anyway, let's continue. Like, they are right dihedral angles, which is 90 degrees. I'm not gonna say that 91-degree right angle again. Anyway, it's 90 degrees. And then when one plane forms a right dihedral angle with another plane, then the planes are perpendicular to each other, just like what's on the figure here. That plane HP and plane M is actually perpendicular to each other. And then we have here the line of intersection LK. Then next, let's continue. Okay, I'm sure we all know this one already. That's since the measure of the plane angle, the measure of the dihedral angle, it's actually 110 GPOU. That's 110. And then 35 and 35 because there are two. Then 110, 70 is 180 degrees. So let's continue. The two dihedral angles are equal if their plane angles are equal. You can see, like I said earlier, the measure of the plane angle. It's also the measure of the dihedral angle. If two dihedral angles are equal, then their planes are equal. If two planes intersect, the vertical angles in pairs are equal. So let's continue. So we now this is where our topic is all about. So this is what our topic is going to be. Now let's solve this one first. Anyway, let me charge my device. Okay, so let's continue. Let's solve this problem that a dihedral angle is 120 degrees. The distance of a point inside the angle from each of its faces is 8 centimeters. So find the distance between the feet of the two perpendicular dropped from the given point onto the faces. So to solve this, we are going to draw a figure. We are going to draw a figure for this one. So let's do this. So we have the figure here like that. And then we have perpendiculars here, the point inside the angle. And we also have the point here, and that is the 8 centimeters, because it's the distance of a point in that angle from each of its faces is 8 centimeters. So this is 8 as well. So find the distance between the feet. So we're looking for this one, that we're looking for that. And this is 120 degrees. So we will divide 60 and 60 degrees. Also goes here. And this is 30 and 30. So let's label this one as A, and this is B. So we are looking for AB. And let's label the point as point P. So let's label the point in the middle as point C. So let's look for triangle. So this is 8. This is A, and this is C, and this is P. And this is 30 degrees. 30 degrees. Because that one is 6. And this is 60. So we are going to do, let's make it, let's do this here. Let's just use some sine cosines here. So sine 30 is equal to AC over 8. And you know that sine 30 is 1/2. So AC is equal to 4. We applied a MPE here, multiplication property of equality. So AC is 4. And also since they are congruent, so let's draw the triangle here for for B, C, and P here. This is B, and this is C. This is C, and that is P. So this is 8 again. This is 30, and this is 60. So we will do the same. Sine 30 is equal to BC over 8. MPE, and BC is also 4. And now we already have the values of AC and BC. So we are going to do some segment addition postulate here that AC is, I mean, that's a plus sign. plus BC is equal to AB. So that's a segment addition postulate. So we have 4 plus 4. Oh, no, 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 no. 4 plus 4 is equal to 8 inches. No, centimeters rather, not inches. 8 centimeters. Since AC is 4 and BC is 4, then the distance between the feet of the two perpendiculars drop from the given point is actually 8 centimeters. We're not looking for the distance of the edges. We're looking for the distance of the two perpendiculars each point. So the answer is 8. And now let's proceed to projections. Yeah, this is our solution. And then now for the projection, we have definition. The projection of a point upon a plane is the foot of the perpendicular drawn from the point to the plane. And then the projection of a line, straight or curved upon the plane, is a set of all points of the plane which are projections of points of the line. So we have here the projection of the point. Let's say we have point A, and the projection is the foot of the point, the perpendicular drawn from a point to the plane. So let's say we have point A. The projection of point A is point E based on the figure. As you can see that the foot of the plane, that is point E. So the perpendicular AE, A is perpendicular to plane MN. So projection of point A is the projection is point E. And then the projection of a line is the set of all points on the plane, which are projections of points on. So we have line AB. So the projection of line AB is the line on the plane, the set of all points of the plane. Projections of points of the line, set of all points. So you can see that AB, line AB is projection is the line on the plane, which is EF, the line on plane MN. And then next, we have here the projection. Projection of PC, PA, and PB. So we have here line PC. The line PC's projection, line PC's projection, this one. And the projection of line PC is line CO because it's the set of points, the projection of the line, or is the set of all points. You can see that line PC is projection is line CO, and based on the definition that the projection of the line is a set of all points on the plane. And then this one, PA, and the projection of line PA is line AO. And then for PB, the projection of line PB, this one is the line OB, and that is the projection of the line. And we are looking for the projection of point E. So the projection of point E, there are a lot of projections here. It can be point C, it can be point A and point O, point B, or point A prime. But based on the definition of projection of a point, is the foot of the perpendicular. P, which is point O. Next, we have another theorem here that the angle which is a straight line makes this the projection of the line. Wait, okay, the angle which a straight line makes with its projection on the plane is the least angle the line makes with any line in the plane. Okay, then just a straight line makes with its projection on the plane, the least angle that the line makes. You can see that the angle which a straight line makes with its projection on the plane. Straight line makes is the least angle that the line makes with any line in the plane. So we are going to prove this one as well. So the angle a straight line makes with its projection on a plane is the least angle that the line makes with any line on the plane. So it means that if it's a straight line, the angle of the straight line. I mean there's a straight line and and a straight line makes an angle with its projection of the plane, and that is the least angle that the line makes because it is a straight line, and that's why it is the least because it is a straight line. Anyways, next practice exercise is the projection of a point. Always a point is a projection of a segment. Always a segment. Can a projection of angle be a ray, a line, segment? Okay, we have here that in the figure anyway. Anyway, let's continue. That in the figure E and F are planes intersecting in PQ. AB is in F is twice as long as its projection. BC, PQ is perpendicular to plane ABC. So we're looking for the dihedral angle APQC. So let's just look into the plane here first, which is the triangle ABC. Then that is the figure E and F are planes intersecting in PQ. AB in F is twice as long as its projection, so that this be 2x. 2x x. Okay. BC and PQ is perpendicular to plane ABC. Then we are looking for the dihedral angle. Okay. Dihedral angle. We're looking for APQC. The dihedral angle. We're looking for that. So if you can see that if this is 1, then this is square root of 3 since we have 1 here. And we have 2 and this is square root of 3. And then in PQ, A, B, and F. It's twice as long as its projection. So let's assume that BC is 1. So if it's twice as long as its projection, so projection is 1 and twice is 2. So we have to multiply by 2 to get the value of AB. So it's 2. And since 1 and 2, then it's square root of AC is equal to the square root of 3. Because this is the 30, 60, 90 triangle. So if you will look into the figure, BC and PQ are perpendicular to plane ABC. So triangle ABC, BC and PQ are perpendicular to plane ABC. You can see here. So we were looking for the measure of the angle of the dihedral angle APQC. So if this is one, that's 2. So this is 30 degrees, and this is 1 is 60. So meaning that the dihedral angle is actually 60 degrees. The measure of angle APQC, that's equal to 60 degrees. Okay, so let's continue. The figure E and F are planes. Okay, so there's like the angle ABC is, or the plane angle is 60 degrees. So therefore, the dihedral angle, the measure of the dihedral angle APQC is also 60 degrees because the plane ABC, the angle is 60 degrees. So let's continue. Find the length of projection on a line 23 inches long inclined to a plane at 60 degrees. So let's draw the figure here. So we have the 23 inches long here and this is the projection. So we have here 23 inches. So we have here 60 degrees. 60 degrees is actually the angle of inclination. So to find the length of projection on the plane of a line, and we have here 60, and the projection is adjacent to the angle of 60 degrees. So we will be looking for the angle, the length of the projection. So we are making use of cosine 60 degrees is equal to, okay, let's label this one as x. Okay, cosine 60. Okay, we're we are actually looking for the projection, so I think I labeled it wrong. So x. So we have here 23. No, 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 no. I mean x over 23. X over 23. So we can apply MPE here. So we have 1/2 is equal to x over 23. We are going to multiply it by 23 over 2. To isolate x, so we have to multiply to 23 rather. So the value of the projection, the length of the projection is equal to 23 over 2 inches. So that's it. Next example, we have here another one. The length of projection, the inclined line is equal to 5 square root of 2 inches. And we are also looking for the length of projection again. And the angle of inclination is 45 degrees. So this is also the isosceles triangle theorem. So the measure of the length of projection is 5 inches. Because what we did is cosine 45, that is also the square root of 2 over 2. And then we did this x over 5 square root of 2. We apply MPA and then we got the answer 5. Okay, that's it. Next. This is, as you can see, here's the solution to this one. You see, it's 5. Next, another problem here. The base of an equilateral triangle 12 inches in length lies in a plane, and the plane of the triangle forms a dihedral angle of 60 degrees with the given plane. Find the distance from the third vertex to the given plane and the length of the projection of each side of the triangle on the plane. So let's draw a figure here. Let's draw the figure here. And this is the plane, and this is the equilateral triangle. And then we have a dihedral angle of 60 degrees. And we are looking for these sides here. We're looking for that. So this is 12. The other is 12 as well. Let's label A, B, and C. And this one has T. So since this is an equilateral triangle, they are all 12 inches. And the A, T, and T, C, they are 6 inches. So we are looking for this. Let's label this one as B prime. So we are looking for B prime, which is the distance from the third vertex to the given plane. And then the length of projections, AB prime and CB prime. So let's look first for BB prime. I mean, let's look first for the value of B and T before we find the value of BB prime. BT. Okay, my triangle isn't perfect. B, T, and C. So this is 30 and this is 60. 30 and 60. So since this is 12 inches and that one is 6, we can do cosine 30 or sine 60 to find the value of BT. So we can do here. Anyway, let's just do some cosine 30 equal to BT over 12. Square root of 3 over 2 is equal to BT over 12. So it means that the value of BT is 6 square root of 3. Now to find the other values, we have here the we will now look for BB prime. And now we have here the 6 square root of 3. 6 squared 3. 6 is square root of 3. So we are looking for BBT. So this is 60 degrees. So sine 60. So that is square root of 3 over 2 again. Square root of 3 over 2 is equal to B prime over 6 is square root of 3. Come on, I can't write properly na. 6 is square root of 3. So apply MPE. So B prime is 9 inches. So we already have 9. And then for AB, we are going to look for the projections. And since it's equilateral, then they are equal. They are equal. Now let's look for CB prime. So we have 9 and we have 12. Now we can do some Pythagorean theorem here. 144 minus 81. CB prime. So 144 minus 81 is 63, or let's say 3 square root of 7 inches. And since they are equal, then that goes the same for CB and AB. 3 square root of 7. Yeah, that is. That is. And then let's continue. So this is the solutions to that on the board. Okay, that's it. So now we are going to the locus of points and polyhedral angles. So what is a locus? Locus is a Latin word meaning place or position. Meaning locus is we are talking about, since we're talking about locus of points, locus is, it means place or position. So we are talking about the position or place of the points in the figure. So definition one, that a locus is the set of all points and only those points that satisfy a given condition or set of conditions. All points and only those points. All points of the locus satisfy the given condition, and all points satisfying the given condition are included in the locus. Meaning that if it satisfies the given condition, then it is included in the locus. And all points of the locus, they are satisfying the given condition. Satisfying the given condition, a set of conditions. And then next is we have locus theorem 1. The locus of points at a fixed distance d from point P is a circle with the given point P as its center, d as its radius. So if you can see that the locus of points from locus theorem 1 at a fixed distance of d from point P, as you can see here, that there's a fixed point, which is, yeah, there's a point P, and there's a locus of points going around. Locus of points at the fixed distance d from point P. You can see it is a circle, a circle with the given point P as its center and d as its range. So locus theorem 1 is a circle. You can see that it is a fixed distance, equidistant. This a fixed distance called the radius, and the set of points equidistant. So it's a fixed point, which is the center. So P is the center of the circle and D is the radius. And the locus of points is a circle. Like I still don't know if a circle is a polygon or not. And then locus theorem 2. The locus of points at a fixed distance D from line L is a pair of parallel lines D, distance from L and on the either side of L. So we have here the locus of points. We have one line, one line here, line L, and there is a locus of the point. It satisfies the given conditions that it is a parallel line. Satisfies the locus point. It satisfies the given conditions, which is the parallel lines. So the locus of points at a fixed distance from line L. You can see that there is a fixed distance, which is the letter D, and from line L, and on either side of L, which is the locus point, we have a pair of parallel lines. That is the locus of points. And the D is the distance from the original line, line L. And there are two parallel lines. And D is the distance from the line to the either of the two lines. Next, locus of points, locus theorem 3. And if you can see that the locus of points equidistant from 2 points, or the line segment PQ, equidistant from 2 points P and Q, or line segment PQ, is the perpendicular bisector of the line segment determined by 2 points. You can see that line segment PQ, there is a bisector of a line segment, and it is determined by 2 points. So that is the locus of points. And you can see that there's a bisector, and the line segment PQ the, and the line from point P and the line from point Q going to the locus of points, they're equidistant. And the locus of points is perpendicular to line segment PQ, if you will see on the figure. Next is locus theorem 4. The locus of points equidistant from two parallel lines L1 and L2. It's a line parallel to both L1 and L2, and it's in its midway. If you can see there, we have a pair of parallel lines L1 and L2, and there's a locus of point, which is another line, in between the two parallel lines. If you can see here, and it's equidistant from two parallel lines. If you can see that it is equal the distance from line 2 and the locus of points, the line in the middle, and then L1 to the line in the middle. That is the locus of points, the line in the middle. And then locus theorem 5, the locus of points equidistant from two intersecting lines, L1 and L2. A pair of bisectors that bisect the angles formed by line 1 and line 2. And you can see here that intersecting lines 1 and 2, L1 and L2 are intersecting lines. And then there's a pair of bisectors that bisects the angle. That bisect the angles that's formed by 1 and 2. You can see that intersecting lines also, the locus of points are also intersecting lines, and they are bisectors. They bisect the angles that formed by lines 1 and 2, meaning they are cutting it into two. You can see bisectors. Locus of equidistant from two intersecting. As you can see, they have the same measures. Yeah, they're equidistant. Then it's a pair of bisectors. Next, now we have the locus of points in space in solid geometry. The locus of points in a plane is a collection or set of all points and only those points which satisfy certain given geometric conditions. So we have a set of points which can be a point, a line, a surface, or a solid, or any combination of these, depending upon the specified conditions, meaning that it is a conditional statement. It's not biconditional. that the locus point in space is a collection set of points, meaning it is a collection of all points, and it satisfies the given geometric conditions that it can be a point, a line, a surface, or a solid, or any combination of these, depending on the given conditions, the specified conditions. Then here we can sketch. Oh, okay, let's do this. So we have okay, you know this one already, I guess. So the locus of points in a plane that are the given distance from a fixed line. Okay. Okay. The locus of points in a plane that are from a fixed line. So number one, this is the fixed line. And we have here the distance here and here. And the locus of points go like this. And then for number two, it is at the fixed point O. This is O. The fixed point O. And it is 3 inches from the fixed point O. And this is 3 inches. So the locus of points is a circle. It is a circle because we have a fixed point O, and the distance is 3 inches. So I'll leave the rest to you. And number three is actually there a pair of parallel lines, and it is midway. So let me just illustrate this like this, and this is the locus of points. Yeah, like that. Next, the locus of points in space is accepted without proof. Fundamental loci is accepted without proof. The locus of points equidistant from the two parallel planes is a plane parallel to the two given planes and midway between them. The locus of points at the given distance from a plane is two planes. Each parallel is each parallel to the given plane and at the given distance from it. Theorem, the locus of points in space equidistant from two fixed points is a plane perpendicular to and bisecting the line connecting the 2 points. So here's the fundamental loci. Yeah, this is the midway one. And then two planes. And then we have here the theorem as well. Yeah, we have the locus of planes here. Because we have from a given plane, it's two planes. It can be from other side and other side. There are two sides in each parallel to the given plane and the given distance from it. The locus of points in the plane equidistant from two fixed points is a plane perpendicular to and bisecting the line connecting the 2 points. Next. Now we are going to proceed to polyhedral angles. Polyhedral angles. So A polyhedral angle is a figure formed by three or more planes meeting at a point. If you can see the definition of dihedral angles, di means two. So it means it has two planes. At this time, we have more than two planes. So we have here a polyhedral angle S, A, B, C, D, E. So we have here the parts. The faces of the polyhedral angle are intersecting planes. You can see these are the faces. We have, I'm gonna mark it like this. So this, 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 and that. We have five, five faces. No, actually, they're not five faces. There are six actually. That. And then the edges are the lines of intersection of the faces. So we have SA, SB, SC, SD, SE. That is those are the edges. And then we have here the vertex, which is the point of intersection of the edges, and that is yes, that's a point of intersection. Excuse me. Polyhedral angle intersecting planes. We have the polyhedral angle as ABCD. That is the polyhedral angle. Next, we have theorems on polyhedral angles. The sum of any two phase angles of a dihedral angle is greater than the third phase angle. So trihedral is we have three planes. So the sum of any two phase angles of a trihedral angle is always, I mean, I don't know, always, is greater than the third phase angle. If you can see that on the figure here, on the figure, we have the faces V, B, and G, and VGA. Those are the same measures. And the third phase is actually the VFE. So we can say that if we add V, the angles of V, BG, and VGA, it's greater than VFE. Any two-phase angles of the trihedral angle will always be greater than the third phase angle. So next, so we have here another theorem. The sum of the phase angles of any convex polyhedral angle is less than 4 right angles or less than 360 degrees. You can see that convex polyhedral angle. If you know convex is regular, it has the same length and same angle measure. So that goes the same with the polyhedral angles. So if the sum of the face angles of any convex polyhedral angle is less than 4 right angles or less than 360 degrees, if you can see that 4 90-degree angles or 4 right angles is equal to 360 degrees. So the face angles of any convex polyhedral angle is less than 4 right angles or less than 360 degrees. So if you can see, that's the same figure here. Let us assume that it is like that. We have here the given theorem 1. Yeah, this is the solution, the explanation of the theorems 1 and 2, where the two angles, any two angles is always greater. I mean, if you add the two face angles, then it is greater than the third. Then for theorem 2, that if you add the face, the angle, any convex polyhedral angle is less than 4 right or less than 360 degrees. So theorem 1, we have here that A plus B is greater than C, B plus C is greater than A, and C plus A is greater than B. And for theorem 2, we have A plus B plus C, the faces of the polyhedral angles, that is less than 360 degrees. Face angles, rather. Next is we have here if two phase angles of a trihedral angle is are 50 degrees and 120 degrees. Between what limits must the third phase angle lie? So since we have theorems here that the third angle, the sum of the two trihedral angles is greater than the third and less than 360 degrees, and it must satisfy both. That if it's one is not satisfied, then it makes the statement false. So we have here's the solution to that. That if we have here the 120 degrees and 50 degrees, if we add them, that is 170. Then if we subtract them, that is 70. So the third phase angle must be greater than 70 degrees, but less than 170. So this is the concept of inequality. So it is the two phase angles, that's 120 and 50. So if we add them, that should be greater than the third. So we must first look for the measure of the third phase angle. So if you look into the solution, third angle must lie between 70 and 170 degrees. So here we have, and it should be less than, the sum should be, it should be less than, the sum of all faces should be less than 360 degrees. So here we have 169 as the third angle, third phase angle rather. So I'm sure it satisfies the given condition here. So that 120 and 50, 170 is greater than the third angle. So that is the explanation of the theorems here. This we need use of the number line. So the third angle, so here's the solution to it. The 120 plus 50 plus, let x be the third phase angle, is equal to 360, is less than 360 degrees. So if you know the concept of inequalities, that we're going to apply addition property of inequality to find the third. So if you add the two, then 170 is greater than the third phase angle. So we apply API again. So the third angle is less than 360. So 170 is greater than the third, and the third is greater than 170. It's less than 170 rather. So it looks like that the third phase angle is 70. It should be between 70 and 170 anyway. And I think that's all for the coverage of for our first exam in solid geometry. So I think that ends our review for solids. At umunti na ang ahao. Anyway, we will have a short break before the review for mathematics of investment. Thank you.